Okay, video lesson 2.5 for quadratics. This lesson is just going to review some of the basic stuff that you learned last year in quadratics, and then you'll have your assignment and you'll go over some of what this video covers and maybe little other things that pop up along the way. So remember that a quadratic usually is in the form where it's ax squared plus bx plus c. A lot of times this is called standard form, but actually your book means something else when it says standard form, and I'll get to that on the next slide. So let's talk about this value of a. This really does affect the parabola more than anything else. So if a is greater than 0, what would you say has to be true about this parabola? If the leading coefficient is greater than 0, meaning positive, well then that parabola is going to be facing upwards, but more importantly, we know that its vertex is a minimum. Now this idea of max and min, this is important with all polynomials, particularly quadratics, okay? But also we know the vertex is important in applications as well. All right, let's think about when a then is less than 0, when the leading coefficient is negative. That's going to flip my parabola upside down, and then I'm going to have my vertex at a max. Okay, what about the third scenario where a is equal to 0? Okay, if a is equal to 0, well then we actually have a line, okay, and there would be no min or max. Okay, this is actually linear, and lines do not have mins and maxes. Okay, so let's talk about this thing which frequently is called vertex form, but actually this is what your book calls standard form. All right, any way you look at it, this is the form where you have to do completing the square to get to, and also this is where the vertex is really easy to find. You can find the vertex in whatever form you want, but when it's in this form, vertex is really easy because it's a shift to the right h units and up k units, so you'd know that your vertex is at hk. You'd also know that you have an axis of symmetry along the vertical line x equals h, because your axis of symmetry goes through your vertex. So let's review how to do completing the square. We reviewed it a little bit in our first unit. This is slightly different because I'm not going to be working on two different sides of the equal sign. I'm going to continually be working only on the right hand side, and there are ways to do this with both sides, but I like to keep it all on this side. Alright, so first thing, I'm going to move this 23 over. I'm not going to deal with that just yet. Now, if there is a number in front of x squared, you need to factor that out of the first two terms. So we have x squared minus 6x. Okay, now, remember, this value right here, okay, off to the side somewhere, you're going to take that number and you're going to half it, and you're going to box it. So you get -3. I'm going to box it because I'm going to use it in a second. And then you square that number. Now, this number right here, it's a magic number. When I add 9 to the existing trinomial, this trinomial will then factor into a binomial squared. All right, now before we do that though, let's balance. What I really did is 2 times 9, which is 18. So I need to balance it out. Now you can either add 18 to the other side, or I can subtract 18 from the same side, which is what I did. All right, and so now we have 2. This trinomial factors into x minus 3, or x minus 3 squared. And this is, again, why we box this, so it'd be really easy to write that. And then -18 plus 23, that's 5. Okay, so now I started off with my parabola in one form. Now I have it in a new form. It's very easy now to write the vertex, which is at 3, 5. It's also easy to write the axis of symmetry. Now write any of this out that you need to. I like to abbreviate a lot. I'm assuming this is just review, not you learning this, but it is just review. Okay, also, is this vertex going to be a minimum or a maximum? Now remember what we talked about on the first slide. It's going to be a minimum because this parabola will open up, so this point is the minimum. Okay, there's some other things that we can find here, so let me switch the color of my pen, and let's find the x-intercept. Oh, real quick, one last thing. Remember that your vertex is just a point on your parabola. So you can check this easily. First off, this x value should be -b over 2a. This is also something you learned last year. All right, you may not remember it, but I promise you it was taught to you. So negative 12, which is positive 12, over 2 times 2, which is 4. Okay, so that checks out. 12 divided by 4 is 3. Now, you should be able to plug 3 in and get 5. So I'm just going to do this mentally. 3 squared is 9. 9 times 2 is 18. All right, then we plug a 3 in here. That's going to give us 36, so minus 36. All right, plus 23. The way I would do this is I would add 18 and 23. That's going to make 41. 41 minus 36 is 5, so it works out. So there's no excuses for getting the vertex wrong. You got 2 different ways to do it in 2 different forms to back each other up. All right, now let's talk about x-intercept. Now we know that you find the x-intercept by setting y equal to 0. Now you can do that in either form here. You can set the top part equal to 0 or the bottom part. If I set the top part equal to 0, this is what we practiced in Unit 1, where we would then try to factor or then possibly do quadratic formula. Since we already practiced that, I would like to go to the next part, which is, since this is already done, I think this is not a bad idea. I don't think it's worth doing quadratic formula just to find the x-intercepts, but since we already did quadratic formula, then finding the x-intercept this method would not be too bad. So I would subtract the 5 over, and I would have 2 times x minus 3 squared equals negative 5. Okay, I'm going to divide by 2, so I'm going to just do that in one step. Same step. That's the nice thing about this pen. All right, now I'm going to square root both sides. Now keep in mind, when you square root, you have to consider both the positive and the negative of this number. Now, we kind of luck out here because I don't really have to go any further because this is an imaginary number. So that tells me that there are no x-intercepts. Okay? All right, let's talk about y-intercepts now. All right, for quadratics, y-intercepts a little bit easier. Okay, this is where x equals 0. So you just need to find f of 0. Always easier to do this in this top form right here, because it just basically cancels those out. You get 23, and so you will have a y-intercept of 0, 23. Do you think it's possible to have no y-intercept for a quadratic? No. You would it's not possible to not have one. You would always have one. Okay, and that's because the domain of quadratics are all real numbers. The range, though, definitely depends on the shifts. All right, let's go ahead and graph this parabola. I'm going to move all this stuff up here. Let's graph this parabola and let's find the domain and range. Okay, so here I have, these lines are pretty straight. Okay, we have our x-axis and our y-axis. And now my vertex is going to be at 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. Okay, and so I'm going to plot that point right here. And so my parabola is going to be facing up. Now, if I asked you to plot more points, well, the easiest point next to plot would be 23 now. Since that's such a big number, I'm just going to write 23. You would also then know that 623 is another point. And this makes it really obvious of why I have no x-intercepts. This is completely above the x-axis. Okay, what's the domain of this quadratic? I already said it. That's right, all real numbers. And range, we look at the bottom number. The bottom y value is 5. I'm going to use brackets here. And then that goes up forever, so infinity. Okay, let's do another example. Okay, so this parabola is going to be facing down, so it's going to change some of the things that we have. Let's start by completing the square. This works out a little bit differently because I'm going to factor out a negative 2. That's going to become x squared minus 2x. Now remember, this plus 4 is not in the parentheses, so I'm moving it over here. We don't factor out negative 2 because it's not within the parentheses. Okay, so we take this number, negative 2, you half it, you get -1. You box it, you square it, you get +1. That's the magic number that completes the square. Now, what I really did is -2 times 1. So I have to do the opposite, +2. Okay, so now I have f of x equals -2, parenthesis, x minus 1. If you're not sure what that number is supposed to be right here, just look in the box, +6. So then my vertex is +1, 6. My axis of symmetry is the line x equals 1. This vertex is a maximum. I know that because my parabola is upside down. And in finding x and y intercepts, let's go ahead and do that. So again, we could either take the original form, we could set it equal to 0 and either do factoring or quadratic formula, or we could take our completed the square and actually set that equal to 0. And again, since we've gotten practice on the other ones, let's go ahead and use this one. So then I'm going to subtract 6 over, and I get -6 equals -2 x minus 1 squared. I'm going to divide by -2, and so that's going to become +3. So this is going to have some x-intercepts. So now when I square root, I'm going to actually move the x minus 1 over. Still don't forget your plus minus, both positive and negative √3, and then add 1, so I get x equals 1 plus minus √3. Okay, so one of my x-intercepts is 1 plus √3, comma 0, and the other one is 1 minus. So I'm going to go ahead and write this as a point using plus minus, cheating just a little bit, but it's okay. Okay, my y-intercept, for finding out what is f of 0. Again, always easier to look up here, and then you can just write it. So that's 0, 4. All right, so let's think about what our graph is. Let's plot a little sketch of this graph. Okay, so I have 1, 2, 3, 4, 5, 6. That is my maximum. That's my vertex. I have 0, 4. I'm going to mirror that point over here. And I'm going to plot my x-intercepts. Now remember, we start at 1 and then we add √3. So how much is √3? Well, √4 is 2. So √3 would be a little bit less than 2. So it looks like right here between the numbers 2 and 3, and over here between 0 and -1. And now you have 3 points plotted. You didn't even have to do a table. On that last one, if I had actually asked for 5, sorry, this is 5 points. I'd ask for 5 points on the other one, which is kind of standard sometimes. You'd have to actually do a table, plug in just numbers. Here we got our 5 points. Okay? Domain, still all real numbers. Range is going to be starting at -infinity, going all the way up into the maximum, which is 6. Use a bracket there. Okay, so that's just a little bit of review of graphing parabolas. The last thing I want to talk about is local extrema. We've already been doing this. These are just local maxes or mins. Now, the reason we use this word local is because it doesn't always apply to the absolute. Now, in quadratics, you either have if you have a local max, it is the absolute max, or you have a local min, it is the absolute min. There's only one. Okay, but with polynomials of higher order, cubic, or x to the 6th, or whatever, you could have a polynomial, let me just go ahead and draw one, that has several. Now, I'm going to go ahead and draw a polynomial. We're not reviewing everything about polynomials. However, I'm going to ask you, does this polynomial have an absolute max? Well, definitely this max is higher than this one. But since this arrow moves up, there's no absolute max. What about an absolute min? Nope, because this arrow is going down, and this tells us that this polynomial is of an odd degree, meaning that its highest exponent has to be an odd number. I'm just reviewing this stuff as we go along so that it becomes easy when we actually have it in the notes. Alright, I want you to put a dot everywhere they have the local maxes and mins. So these two things right here, these are local mins. These things right here, Those are local maxes. All right. If you were given a polynomial and I asked you to find these local mins and maxes, right now we would use the calculator. You know how to do it with a quadratic. You don't know how to do it yet. We will get to this before the end of the semester. You don't know how to do it yet for other polynomials. So you're going to use a calculator, and on your calculator, if you hit second trace, this is also a good way to check your vertex for quadratics, but you can do second trace and you can either select max or min. Now you just have to do the correct lower bound and upper bound, or left bound and right bound. It only will find the min within that section, okay? And when it asks for guess, you just guess. Although the guess, you could guess whatever you wanted. It just depends on how long it'll take you. Okay, bring your questions to class.